For the next sharing, we would like to introduce José Antonio Irastola Rodríguez. He's next to me, Business Development Director from Ryzen Energy. Please give a big applause to welcome him.
So thank you. Good morning, everyone. Just wait a minute so that we can see it. But well, during the morning, we've been already hearing a lot about sustainability and reliability. So this is why we are here today to introduce you our new product, Hyperion heterojunction module, which is a... Okay, sorry. Okay, I thought it wasn't prepared. So it is a ultra-low carbon and ultra-high efficiency module. We will show you why we speak like this, like the new heterojunction era. And I drive you through the characteristics of this heterojunction module. Afterwards, we will see the system matching and economic analysis and capacity planning. This is only a brief presentation. Afterwards, you will have my contact information, so I invite you to write me and reach me so that I can fulfill your inquiries, okay? So, well, why we say this is the N-type era, and I think no one has a doubt that nowadays the next trend is to have N-type modules in our installations. This is mainly because P-type PERC modules are reaching to the maximum efficiency, which is 34.5 efficiency. Nowadays, we are mass producing 24% efficiency. So we are jumping into N-type technology that may reach efficiencies up to 28%. Okay? We expect next year, 2023, to be the kickoff for this new technology, N-type. And then from 2024 on, we will see a roughly shift from P-type PERC to N-type. By 2029, we expect P-type PERC to be disappearing. Okay? So the comparison among the different N-type cell technologies, we already learned that P-type PERC is uneconomical compared to P-type PERC. This is why we are dropping that technology already. And then we jump into TOPCon, which is the good part of N-type TOPCon is that can be developed from P-type PERC lines. But the bad part of that technology is that it has a complex process, and roughly 4% of the cells are lost during the process, which is double than the heterojunction process. Also, it's compared to heterojunction, in terms of yield, efficiency, and technology, and scalability, heterojunction is ahead. So this is why, from Ryzen Energy, our biggest bet is to go for a heterojunction. Even though we are still developing TOPCon lines, our biggest improvements will be coming from heterojunction. So heterojunction is a high-efficiency power generation, ultra-low carbon footprint module, which has a thinner wafer that we will see afterwards, low silver content, and it's already competitive in the market. So we are already producing this type of module. And for sure, IBC modules, which is back contact cells, will be coming next. We are also putting efforts in that direction, but today is not a mass production, is not yet achieved. So now we are in a heterojunction era. So from Ryzen, we know heterojunction for the first 4 previous years. We've been manufacturing these modules in 156 millimeters modules. And in fact, we've been the top one exporters in the last 4 years. At the end of 2021, we already reached modules with 721 watts peak, which is an efficiency of the module of 23.65. And this is certified by TÜV Süd. So this is feasible, and we are showing you that this is what is going to come. Okay? So first half of this year, we jumped from 156 millimeter cell to 210 millimeter cell. And we are already producing 132 half-cut 210 millimeter cells. From next year on, we will be implementing our mass production lines, reaching 5 gigawatts by the end of the first half of the year, And by the end of 2023, we expect to have 15 gigawatts of mass production of heterojunction. So in terms of at a cell level, we see a 24 busbar cell, with lower cost and higher efficiency. Also, this technology is called heterojunction because it has a thin film, amorphous film in between the NP type, and it gives us a higher open voltage. So this gives us a very low power temperature coefficient. What this leads us is to have less impact at higher temperatures, which is very interesting. And also, thanks to the ITO, this is a best anti-PID performance. And since we don't have boron oxide, there is no LID caused by BO. Okay. Also, we are reaching nowadays 25.5% of cell efficiency with a 120 micrometer cell, and 90% of highest bifacial factor, which is also an improvement from TOPCon. Talking about temperature coefficient, if you compare HCT technology with the rest of the technologies, P-type PERC nowadays has surroundings of 0.34, TOPCon minus 0.32, and heterojunction minus 0.24. This leads us to have up to 3.2 increase in production when we are in extreme conditions of temperature. And nowadays, P-type PERC and TOPCon thickness of cell is roughly around 160 micrometers. With heterojunction, we have put a lot of technical effort to decrease up to 120 micrometers. This is 25% less of silicon consumption in our modules, which lead us also in a huge impact in carbon footprint. And we are expecting to go down up to 80 micrometers. By duplifying the number of busbars, we are also multiplying by 2 the number of contacts between the fingers and the busbars. So in the event of a microcrack or a discontinuity in the fingers, the electricity will find easier the path out of the cell. So when you have the whole module, we are right now in mass production of 132 cell half-cut 210 millimeter heterojunction modules, and with power rated between 680 and 700 nowadays, and with efficiencies from 21.9 to 22.5. And as you may see down, another big implementation is including a steel frame in our modules. And why a steel frame? Well, steel frame because we are seeing that in extreme wind conditions, when using the bolts and the mounting holes for the installation, that we find that tear resistance might not be enough in aluminum. In fact, we have done performance tests, and if you compare the tear resistance of the aluminum versus the tear resistance of the steel, we have 30% more resistance. And normally, when we tell the people we are implementing steel, the first concern is corrosion. So it took a while to be developing this product, and it's a unique surface treatment process from Ryzen Energy that gives us an excellent corrosion resistance, and we are passing all the globally accepted tests, and moreover, we are making ×5 and ×3, and still reaching the limits that are required. So this steel frame has an excellent corrosion resistance. And talking about carbon footprint, if you compare the life cycle carbon emissions of the raw material aluminum versus steel, aluminum has 7.2 times higher emissions than steel has. And if you come down to the module level, including the transportation of the modules, aluminum and steel versus steel has 4.5 times lower emissions than aluminum. So this is also why we are reaching a better carbon footprint in our new heterojunction Hyperion modules. So overall, and coming back to the previous points that I have mentioned, if we talk about an easier process, low temperature process for heterojunction, also a thinner wafer of 120 micrometers, and still the change in the steel frame with lower emissions in its life cycle, we are reaching a carbon footprint of 400 kilograms equivalent of CO2 per kilowatt peak, which comparing to P-type PERC, which is in the surroundings of 600, and with TOPCon, which is in the surroundings of 500, it's a huge reduction on the carbon footprint. And this is also something that is being key for many projects that we are being involved nowadays already. So last but not least is linear warranty is highly improved. Now we are talking about a module that has 0.25 degradation per year. So this is the unique technology that ends up in year 30 with more than 90% of production guaranteed. Okay? So since first year guaranteed is 2%, TOPCon has a better guarantee for the first 8 years, but from 8 years on, heterojunction is the best in Plaza guaranteed power rated. So all of that is our Hyperion module. It's an ultra-high efficiency, ultra-high energy yield, ultra-low carbon footprint with an excellent warranty that will impact directly lowering down our BOS and then also LCOE. Right now, we have been the first along the world to be granted with ISC 61215, ISC 61730, among others, and we have already the TÜV SÜD certificates that we can share with you if you require. And this is to show you that this is a reality. We are already ready to export this type of modules, and our lines are implementing day by day. So nowadays, our lines are ready to prepare utility scale modules, but we are already mounting our lines to be ready to fulfill all the market requirements. So we will be making modules not only for utility scale, but also for commercial industrial rooftop and residential rooftop. And one of the main concerns of our customers is to receive new modules is how is this compatible with my existing suppliers. So we have proven already that our Hyperion series products are completely compatible with our mainstream inverters worldwide, so this is not a problem. This is a simulation with PVsyst, and just to show you how in different areas of the world with different temperatures, 24.7, 23.5, and 27.7, the most extreme conditions, the difference is creating a Hyperion series. So, for example, we are reaching 7.27 higher production compared to P-type PERC bifacial module in a plant installed in Saudi Arabia. Okay, and this is due to also a thermal coefficient, power thermal coefficient. This previous slide was a simulation. This is real values checked by a third party, where we are reaching 9.63 more production of P-type PERC monofacial. So it's very nice production. And this is another installation, 100 megawatts fixed tilt in China, where we are reaching a reduction of 10% compared to P-type PERC, while TOPCon, it's only reducing 2.1% in LCOE. So this is, again, why from Ryzen we are making our biggest bet in heterojunction. Our capacity is planned to be reaching, as I told you, 5 gigawatts by first half of next year and 15 gigawatts by the end of next year. And this is only to show you that we are not only creating lines for modules, but also we are accompanied by creating the cells. So to be able to fulfill our own requirements and to fulfill our customers. So this is all. It was very brief, but please, you have my contact information over there. Thank you for your time, and you have any query, please reach me at any time.